Hello, for this video we are going to be looking at volume of solid evolution or volume of revolution. This topic is actually an application in integral calculus, and it's very important in areas where we calculate volumes of shapes, especially irregular shapes. Let's take for instance a shape that looks like this. Let's say we have a shape that looks like this, like this. So this is solid shapes. Solid shape is not really a cone because you see that it's having a curve. This line is not a straight line, and this is not also a straight line. So, but let's assume we have the equation of this curve given as y is equal to x squared. So, how can we calculate the volume of this figure? So, that is the application of volume of solid evolution. But before we come back to this, let's start using a simpler example. Let's draw another Cartesian plane. Let's say we have another Cartesian plane. Then we have a line. This is our line. Let's call this line y. Let's call this line y is equals to 4. That is, this point is 4. Then let's assume that we want to find the volume when this line from this point to this point. That is, let's call this difference between these 2 points, let's call it delta x, because this is our x axis and this is our y axis. So let's assume that this line, which is equal to y is equal to 4, makes a 360 degrees revolution. That is, it turns around, that is, it goes to the other end of the Cartesian plane. That is, it's going to come exactly to this point, minus 4. So we are going to have something like this. If we should make a 360 degree revolution, so this is it, the same boundary of x. So that means it's going to give us a cylinder. It's going to give us a cylindrical shape. It's not really a perfect diagram. It's going to give us a cylindrical shape. This is it. Is a cylinder. It's giving us a cylindrical shape. And we all know that the formula for the volume of a cylinder is pi r square h. That is the formula for volume of a cylinder. So what this simply means is that we can compare this formula and this particular illustration. In this illustration, our h stands for delta x, while our r in this case is the radius of the line, that is the distance of the line from the origin, that is from x equals to 0. So that's our radius, and it is mostly given as y. So by substituting this value for h and this value for r in this, is going to give us v as equal to pi, our r now is y square delta x. But writing this in integral form, it will simply be equals to integral of pi y square delta x. So in a nutshell, this formula is simply the formula that we use in calculating the volume of any given line that makes a 360 degrees revolution. So we can come back to this particular shape now. We can see, unlike this particular shape, this is a cylinder, which is easier to calculate the volume. So, but in case wherever we have lines or we have shapes that are not regular, like this particular shape, we can simply put the value of y, which is equal to x squared, into this formula. Then we calculate our volume. Then our delta x will simply be the distance. Let's as we want to even calculate the volume between this point here and the end of it. We simply slot the values of x and the value of y into the formula, this particular formula, and that will give us our volume. So it's a very, very important application of calculus. No matter the pattern of the line, Even lines that are like this, that looks like a quadratic graph, something like this, we can use this formula to calculate where this line makes a 360-degree revolution. What is the nature of the shape that's going to give us? We can use this formula to calculate it. When you have lines that are like this, even lines that are like this, let's say this line makes a 360-degree revolution. You slot into this formula. You only consider our boundaries, and that will give us the volume of our solid revolution. So in the big part of the question, we are going to look at the application properly, and we are going to be considering the sphere. So I would like you to also check the B part